reflection. What is reflection?
The idea of
So when we talk about reflections, what we're basically saying is that a wave propagating forward will hit a reflective surface and bounce back
at the same angle.
at the same angle with respect to yes. That is a mistake I have seen so many people make. So the angle of incidence equals angle of reflection. And why do I draw these lines? To show that this is a wave propagating. It's not one line. This shows wave propagation. And that is what reflection is. Theta I equals theta F with respect to the normal to the surface. Number 2, refraction. What is refraction? When something goes through a surface. Very good. And anybody remember the law that this follows? If this is N1 and this is N2, it's called the Snell's law, thank you, which was defined as here's another concept that gets very confusing. I want you to be very clear about these two words. They are two sides of the same coin. Superposition is the phenomenon, and interference is what results. If two waves come in, they will do what we call superimpose on each other. When two waves come in, they superimpose on each other, and the result that we get from it is called interference pattern. So the result that we will get will either be doubling the size of the incoming wave, or you'll get nothing out, or you will get partially double, partial, and some places zero. These phenomena are called constructive interference, destructive interference, or intermediate interference. Okay, number 4, diffraction. If a wave sees a barrier, what does it do? This is a wave coming in. It will diffract depending on the opening. This is why you can hear around corners, because sound waves can go around corners. But have you ever seen light coming through a cloud? It starts small there, but then it becomes bigger as it comes down, even though it was like coming all straight at the top, but then it diffracts around the corners. That's called diffraction. So the bending of a wave around an obstacle is defined as diffraction. Bending of a wave around an obstacle is called diffraction. For light, it casts a geometric shadow of the obstruction. So if it's circular, you will see the rays coming out that are diffracted sort of like a circle. If it's a square, the light will take on that shape. If it's a, whatever shape it is, it'll take that on. Yes, incoming wave that way. Okay, last one, number 5. Polarization. What is polarization?
Like never.
As far as electricity goes, or as far as like how electrons separate, positives and negatives are separated from one another.
So let's talk about waves. So an unpolarized light wave looks like this.
Yeah.
It goes in all 3 dimensions. It has E's and B's and E cross B's and all that kind of stuff. And it's a 3-dimensional craziness. When it goes through a polarizer, it gets polarized in the direction of the polarizer. So when it comes through 2 polarizers, it does that. However, if you have this, instead of this, you flip one of them. So what will happen to light? So it goes this way, it's polarized, and then it goes to nothing. So this is unpolarized. This is unpolarized light. This is polarized twice. And this is rotated polarizer. So the intensity of unpolarized, if I take this one to be I0, then I can say that the polarized intensity will be 1/2. And this intensity will be given by what is called the Malice's law. And he said this, where I is the intensity of the unpolarized, I0 is the intensity of the unpolarized light, I is the intensity of the polarized light, and theta is the angle at which your polarizer exists. Okay, let me write that down. I0 is what?
The unpolarized.
Unpolarized light intensity. And theta is what? The angle between transmission axis and the initial polarization.